competition will yield something big. All right, hello, 1 December the 10th. All right, let's do this. Oh, it's not the second version of the same problem. I actually have some idea about how I will do this. We'll wait for a future opportunity to investigate that, which I'm more than happy to, actually. Okay, let's take a look at today's question. I think this is something we've done before. You're given 0-index array nums and a non-negative integer k. In one operation, you can do the following. Choose an index I that hasn't been chosen before from this range. Replace nums I with any integer from the range. Okay, in this range, minus k and plus k. The beauty of the array is the length of the longest subsequence consisting of equal elements. Return the maximum possible beauty of the array. After applying the operation any number of times. Note that you can apply the operation to each index only once, but you can apply it any number of times. A subsequence, we know what a subsequence is. So we say we can replace nums I with any integer in this range. So choose index 1 and replace it with 4. And choose index 1, choose index 3, 0, 1, 2, 3. And replace it with 4. After the applied operation, the beauty of the array is 3. I don't understand. Oh, is nums I minus k? My bad. So if I choose index 1, that's 4 to 8 from range 4 to 8. Oh, it's the range is not the range of the indices, but any number from 4 to 8. So we get 4. If it's 1, that's negative 1 to 3. For 2 is going to be 0 to 4. Okay, so I see. And because it's subsequence, it doesn't really matter your order. So I think I would first of all change, and we can change the order of the numbers, right? We change the order of the numbers, and basically for each number I have a range, right? So what we want to find is what number will be covered and we want to find a maximum possible beauty. Maximum possible beauty. The beauty is the longest subsequence consisting of the equal. Okay, the longest subsequence containing equal. If we sort the array, then the longest sequence will be a subarray, right? Because the k is the same. So if I have a number on my left, we can reach the target number, and I have a number on the right, I can do it, and I can do it too. So we convert this problem into, we sort this number first, and we are asking which subarray will give me the longest subarray, right? The same. And with that, what we can do is also create a range, right? So the range will be -1 so it's -1 to 3, right? And then this is 0 to 4, 2 to 6, and 4 to 8. So we do that, and what we want to see is what is overlapping in all this. I mean, in this case, if you see 0 minus 1 to 3, 0 to 4, and 2, so we can actually do 3 as well, right? If we binary search this, we can say I want the length to be, to be anything, and we can sliding window to see if within this window we can achieve it, right? We can achieve it. So now the question is, how do we know if there is something in common in the sliding window? So if I starting from here, right, -1 to 3, and then I go to the second window, and we have the common, we can say, okay, the common is 0 to 3, right? This is the common. And now we go to the next one, 2 to 6, right? 2 to 6, now the common is 2 to 3, right? And let's say, okay, so this is possible. And if it's not possible, right? If it's not possible, let's say I go here and then it's not possible, right? It's not possible, so, but we need to move to the, right, it's not possible, then we shall remove this, right? Remove this. So remove this, we are removing the restriction on 3. But we need to know what's the current biggest. Well, because we sorted, so we know the current biggest is here, right? So we say, okay, I'll remove the restriction because the restriction comes from the first, right? Because everybody is going to be like this. Well, of course, it might be like huge, right? It might be huge, but it doesn't matter, right? It doesn't matter because we sorted it. So as it grows, right, we know the right and just keeps moving. So the first one definitely gives you this, right? And the last one will give you this, right? So first one give you this, last one give you this. So as we go through, we try to add a new one and say, okay, so it's not possible. Then we will remove this. Remove this means we bring in here, so this will become 4, right? We bring in this, and then we will update. This will become 4 as well. Yeah, so we just go through, and each time when we add a new one, we will, yeah, because I have a range, right? So we have from what to what, and I get a new one, and the new one determines this value because it's more, this one is more towards the right. So we use this, so we replace, so we try to see if this compared to this, right? If this is smaller or equal to this, we can do it, okay? And then it's good. And then once one of them is good, we can move it, make it bigger. And if we have, we will try to add it, it's not good, so we remove the previous, which means we'll replace this with this. Right? We replace with this, because this is the, yeah, we replace with this. And so basically we have this, right? And then we just check. Then we don't even have to need, we just need the 2 pointers, right? This is the 1 pointer, right? And then we move J forward, right? Every time a J will pop whatever it's, because yeah, we pop whatever I, which this is smaller than this, right? So we pop it, and we just move I forward, and then we all put the J, right? And then we move on to the next one. Again, we'll pop everything that's this, and then if we have a J, and then we will, yeah, we keep moving J forward. And all we want to see is if we have a range that is fitting, right? If it is, then if it's not, okay. That seems to be a sound solution that we're going to try. Okay, so we have int low, low should be 1, right? Because we are saying is what's the maximum possible beauty. So low should be 1. High shall be the length. So we can say nums dot length dot size. And then we need to sort. Okay, we sort them and say while low is smaller than high, let's do +1, okay? And then we say mid is high, low plus high minus low divided by 2. Okay, so now we just want to check, right? If we can hit mid. So we have int I equal to 0 for int j 0, j smaller than. All right, let's do n equal to nums dot length, nums dot size. So this is n j plus plus. All right. So first thing we want to check is, actually j can be 1. Oh, they're the same. Right, and then we just say whether we do this, right? And while I and is smaller than j start I plus plus, right? So we say while I is smaller than j and nums I1 is smaller than nums j 0, right? That means they have no overlap. Then, in this case, I++. Right, otherwise, and then we just, yeah, and then, because we accept j first, right? We accept j first, and then we reduce I. So once it's reduced, then we just check if j minus I plus 1 is equal to k. Now equal to mid. My bad. Is this a plus k is smaller than this minus k, right? So if it's equal to mid, then we have done it. Then we shall break. Let's also have a Boolean value called success is false, right? And this basically we say success is true, and then we'll break. Okay, so once this is done, we say if success, that means we can make it even more. We say low equal to mid plus 1, right? We can make it even longer. Otherwise, we say high equal to mid. So when we get out, low, mid plus 1, and then it came out. So we shall return low minus 1. I don't know where this 1 and 0 come from. It's a 2779 binary search and sliding window to find the longest binary search. Right. First sort nums, and then sliding window to find the longest. Right. Sliding window to find. Oh. Then why do you binary search? You just go through the whole thing and then find the longest. Right? Yeah, what's the point of there's no point to find the longest subarray that share, right, the same number subarray and whose ranges of k share the same overlapping number. I don't know why you do this. Don't think this is, and I think we should have a res equal to 0, right? And then for this if we shall just say res equal to std max res j minus I plus 1, right? Don't need this. We probably do need this, and then we'll return res. We do need an I, so let's do I equal to 0 as well. Okay. Yeah, I don't know why I was thinking about binary search. All right, we'll take a look. Looks good. I do need to say that this is ON. All right, we'll try it. Okay, we have done this many times. This is the 3rd time, I think, that we've done it. Actually, no, this is the 1st time. And I make it better and eventually make it very good. Actually, this is This is even faster. How? How? How is Java faster than C++? Where can we optimize? I don't know. Where can we optimize? Sort it, do this. Alright. I think this means there's no overlap. Then I plus 1. That is actually true. But what if I have a ton of, like, the current one is really far? Oh, then you're shrinking, so it's fine. I mean, this is fine. I don't understand. We already got. Yeah, this is exactly the same. Oh, I don't know why the other one gets. Yeah, you can still do binary search. I mean, I don't understand why. Find upper bound. Find the farthest index. Oh, you sort it first and then you can find. I see what you did there. But sliding window is the king in this. Oh shoot, it is open login. Linesweep. It's open login. I forgot about the sorting. Damn it. Okay, what's this Linesweep? A piece of cloth on a number line to represent a range of value each number can span. The ranges overlap. The cloths stack on top of each other. Our objective is to identify the point with the most layers of cloth and count those layers. To implement this count, we'll create an array count to represent the entire possible range of values. So this is the sorting part. So for each range, you just add values to it. We'll mark the start and end position of each range. I have a start and end. Oh, that's the line sweep with +1 and -1. Ah, yes. You do +1 and -1, then you go through this, and essentially you do prefix sum. Then you have, this is the line sweep. You have at each number how many times it has been covered. That is good. That is very good. You find a maximum. Yeah, that's to create the array, and then you go through. You will increment at the start and a decrement at the end. And you go through, you get it. Okay. Oh, wow. You want to try? I think it's interesting enough that I want to try. So this is the solution. This is the Linesweep solution. All right. For each number in nums, we have a range. The question is to find the most overlapped, right, number. The most overlap, right? The most over the count, the count of most overlapped ranges. This can be solved by Linesweep, right? Where we +1 on all the starts and then -1 on all the ends. This way, we can we will be able to identify the most overlapped, right? The most overlapped part. Okay, so what we're gonna do is we'll have a max num for int nums max num equal to std max n and max num. Okay. Now what? Now we can say std vector int Linesweep. We can say it's gonna be max num +1 and the default value will be 0. Okay. And then we'll just go through for nums again, right? And we'll say n minus 1, n minus k. So we say Linesweep std max 0 n minus k, right? That's what plus plus, and plus k. Yeah, because the thing is, it won't be anything larger than the max num. Because if it's larger than the max num, if that one give you, right, then anything smaller will give you as well. So we can just say Linesweep std minimum max num and n plus k. This will be minus minus, right? And then we say for int I equal to 1, I smaller than max num and I plus plus. So basically we will prefix sum this Linesweep. I shall equal to plus equal to Linesweep I minus 1, right? And then we have res equal to 0. So res std max res and Linesweep I. Actually, this shall be Linesweep 0. Yeah, this is produce the number of overlaps at each position. on plus max of nums. None of these solutions has anything to do with k, if you notice. Okay, we'll run it. Linesweep looks good. Linesweep does not look good. What did we do wrong? Input expected 1, but okay, so Linesweep. So max num is 100,000, right? 100,000. It or plus plus, and it or minus minus. Ooh, so we plus and then we minus. Because I start from this and I end from this. I think I should say equal to 1. Because at least it's going to be 1. Just guessing. How about this? std max 1 and line sweep as 0. Because it cannot be smaller than 1. Try it. Okay. That is no good. $29. Because we are creating a range, so in this case a 0 will be plus plus, and then maximum plus plus. Because the entire range, actually no. So this one 13, so basically we have 0 to 42, right? So 0 plus plus, ooh, 42. That's actually, 42 is plus plus. Is, because 0 to 42, I think it should be plus 1. I don't know, just trying some fixes. There we go, yeah, it should be plus 1. There we go. That is fast. Okay, I think the slow is because there's sorting. Sorting is creating the slowness. This one doesn't have sorting, so it's much faster. Okay, that'll be it. No desire to do another one. Let's call it a day. I'll see you guys tomorrow. Adios.